Welcome all for the happy learning in data structures and algorithm. Today we are going to start with the fifth module, which is about graphs and sorting. The first of our fifth module will be about graph ADT, and the second of our fifth module will be about the sorting techniques and the searching we have in a data structure. Today we'll start with the first session about the introduction to graph and what are the terminologies we have in a graph. How do we define a graph? Graph is nothing but a non-linear data structure. We know that usually a data structure is classified into two categories. One is linear data structure, the other one is non-linear data structure. In a linear data structure, we have a sequential arrangement of data, whereas in a non-linear data structure, we have a random arrangement of a data. And graph is represented by the formula G is equal to V by E, where G represents the graph, V represents the nodes in the graph, and E represent the edges in the graph. Okay, and we use this graph to represent the relationship between the objects. How do we do this? We use the two terminologies, nodes and edges. The nodes are nothing but the data what we represent, and the edges is nothing but the how these data are connected, how the nodes are connected. We define that in the terms of edges. Okay, we have several terminologies in the graph. The one among them is adjacent node. Okay, adjacent node is nothing but a node which is adjacent to a particular node. For example, if you have an edge, E is nothing but the edge of the U and V. U and V, we call that as an adjacent to each other. Okay, then the preceded node is nothing but the previous node of a particular current node, and the successor node is nothing but the follower of the current node. We will see that with an example. Okay, see here what are all the nodes we have. Nodes is nothing but the data what it is containing. So 0, 1, 2, 3, 5, 6, 7 are the nodes, what we call them as vertices. Okay, and the edges is nothing but the direction, flow, the connectivity between the vertices. That is 0 to 1 is an edge, 1 to 2 is an edge, 2 to 0 is an edge. Okay, these are all the edges. Again, we have one more terminology as undirected graph. A graph is said to be undirected graph when it is bidirectional. What is bidirectional? When the edges, the flow of edges is done by the two ways. For example, here we can go with the flow of edges from 0 to 1 and the vice versa, that is 1 to 0. Similarly, you have 0 to 2 and you have a path back from 2 to 0. This type of graph you call it as undirected graph. You don't have it is bidirectional, it is not unidirectional. You don't have a flow of edges over here. So what are the vertices we have in this graph? 0, 1, 2, 3, 4, 5, 6, 7 are the vertices. And edges we have 0, 1, 1, 0, 1, 2, 2, 1, 3, 4, 4, 3, 4, 6, 6, 4, 3, 4, 6, 3, 5, 7 and 7, 5. These are all the edges given in this undirected graph. Then we have a directed graph. In a directed graph, the flow of edges will be unidirectional. That is, it indicates the flow of direction, flow of data. See here, it is only the flow of edge from 1 to 2 is, it is 1 to 2, it is not 2 to 1, it is unidirectional, it is 1 to 2. Again from it is from 2 to 4, 2 to 5, 5 to 7, 6 to 5 and 3 to 6. It is not bidirectional. It is specifying the direction where the edges flow. So what are the vertices you have in this given graph? 1, 2, 4, 5, 3, 6, 7. These are all the vertices. And what are the edges we have? 1 to 2, 1 to 3, 2 to 4, 2 to 5, 3 to 6, 6 to 7, 6 to 5 and 5 to 7. These are all the edges which we have in the given graph. Next is weighted graph. A graph is said to be weighted when it is assigned with a cost. Okay, what is cost? We'll see what is cost. Cost is nothing but the value assigned for an edge. See here, the first diagram is weighted directed graph and the second diagram is weighted undirected graph. In the weighted directed graph, you have a flow of direction The weight of the graph, weight of the edge from B to A is 10, from C to B is 20, E to A is 7, and A to D is 60, and C to D is 32, A to C is 12, and C to B is 20. This is in the case of weighted directed graph. The second example is weighted undirected graph. It is bidirectional. You don't have the flow of edges. So it is 0 to 1 is 3. Again from 1 to 0 is 3. This is what a weighted graph is. Weighted graph is nothing but a cost is assigned to the edges. Next is cycle. Cycle. When do we say a graph as a cycle? When you start with a vertex and when you end again with the same vertex of the node where you have started, then you say that as a cycle. For example, see in the first diagram you have 0 to 1, 1 to 2, again you have 2 to 4, again from 4 to 2, 2 to 3 and 3 to 0. So it has been started with the vertex 0 and it has ended with the vertex 0. So this is a cycle graph. We can have a cycle graph in both the cases, in directional graph, in unidirectional and bidirectional. Both the cases we may have a cycle. So in the second diagram again we have a cycle. It starts with A, B, D, G, H, A or A, G, H, A. So you can start with a node and you can end with a node, which is creating a cycle. This is what a cycle we have in a graph. Next is neighbors. Neighbors is nothing but the node which is the node surrounding to it will be the neighbors. For example, for B the neighbors are A, D, C. For D the neighbors are C, E. For G the neighbors are H, D, F. The adjacent nodes you call it as neighbors. Then we have a degree of node. Okay, degree of node is nothing but the weight what it has in a graph. And again this degree of node will be applicable for both the cases, undirected graph and a directed graph. In undirected graph you don't have, since it is of unidirectional, you cannot classify further, but when you have a directed graph you can again classify that into in degree and out degree. In degree is nothing but the number of incoming edges and out degree is nothing but number of outgoing edges. We'll consider this for an example. Okay, so what is the incoming edges? So for 0 the incoming edge is 3 to 0. What is the outgoing edge for 0? 0, 1 is the outgoing edge. Okay, so this is in case of directed graph. In undirected graph 0 has incoming degree of 0 to 1 and 0 to 3 in case of undirected graph. Next is connected graph. Okay, when do you say a graph is connected? We say a graph is connected when we have a path between each pair of nodes. See, for A to B, when can I say I have a connected? When can I say it is a connected graph? When I have a path from particular node to the other node. So from A to D I have a path. From D to C I have a path, and C to B I have a path, and B to A I have a path again. So this is called as a connected graph. When you start with the starting vertex and when there is a possibility of visiting all the nodes in the graph, you say that as a connected graph. Okay, then we have a strongly connected graph and a weakly connected graph terminologies. In a strongly connected graph, when you have a root, when there exists a root between each pair of nodes, you say that as a strongly connected graph. See here in the diagram, it is specifying. See, for C to E, when you consider there is no root. See, when you consider the vertex C and E, you have a flow of direction from C to J, J to F, F to H, but from H again H to E you don't have. So when it is not strongly connected, when you have the root, okay, with each of other vertices, then you say it is a strongly connected graph. And weakly connected graph, when there is no edges, there is no path between the edges, you say that as a weakly connected graph. Then we have a complete graph when you have a direct edge between each pair of nodes. You say that as a complete graph. See, for the particular first point, you have direct edge for all other vertices. Can you take the second point of vertex? Again, that is connected to all the rest of the other pair of vertices. Similarly, entire graph, it is connected with all the pair of edges and all the nodes are connected each other. There is an example for a graph, and we'll see what is the vertex we have, what is the degree we have. Okay, so we have 8 vertices here, 0, 1, 2, 3, 4, 5, 6, 7, 8, and for 1, what is the degree, number of edges it has. For 0 we have 2 edges, that is 0 to 1 and 0 to 7. For 1, how many edges we have? We have 3, 1 to 0, 1 to 7 and 1 to 2. Similarly for 2, how many edges we have? For 2 we have 4, that is 2 to 1, 2 to 3, 2 to 8 and 2 to 5. For 4, how many edges we have? For 4 we have 2 edges, that is 4 to 3 and 3 to 5. Similarly for 5 we have 4 edges, that is 5 to 4, 5 to 3, 5 to 2, 5 to 6. This is how you determine the edges for a given graph. The edges can be determined for both the cases of graph, whether it is an undirected graph or directed graph, the edges can be calculated. And this is in the case of directed graph. When it goes to the directed graph, we have 2 partitions over there, that is in degree and the out degree. So again we have 7 vertices here. Okay, and since 0 we don't have we don't have 0 here. It starts with 1, 2, 3, 4, 5, 6, 7 vertices. And since 1 is a starting node, we don't have a source vertex. We don't have root for 1. Okay, so the incoming degree of 1 is 0. Whereas the out degree is from 1, we have 2 out degree, that is 1 to 2 to 1 to 3. Similarly, when you go to 2, you have an in degree of 1, that is 1 to 2, and out degree of 2, that is 2 to 4 and 2 to 5. When you go with 3 has 1 incoming in degree and 1 out degree, that is 1 to 3 is the in degree and 3 to 6 is the out degree. In case of 4, you have 1 in degree and 1 out degree, that is 2 to 4 is an in degree and 4 to 7 is the out degree. When you consider 5, you have 2 in degree, that is 2 to 5 and 6 to 5, and 1 out degree, that is 5 to 7. This is how you calculate the degrees of a given graph. Now we'll see the path. For example, how to determine a path of a graph. See here, from 1 to 7, what is the path? Okay, what is the path we have? You may have a direct path, that is 1 to 7, the path is 40. Okay, we have even other path, 1 to 3, 3 to 5, 5 to 7. But since we have a direct path over it, the path length is 14 here. Thank you all. This is all about the introduction to graph data structure.